Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. In alkaline conditions, glucose, mannose, and fructose are interconverted via a common enediol intermediate, Lobry de Bruin Alberda van Ekenstein rearrangement. Moving on to the next step. Identify the structure. The given structure is a 1,2-enediol of a hexose sugar. It has AC is equal to C double bond between C1 and C2 with OH groups on both C1 and C2, making it an enediol, enol form. Moving on to the next step. Recognize what sugars share this enediol. D-glucose, aldohexose with ChO at C1, D-mannose, C2 epimer of glucose, aldohexose with ChO at C1, and D-fructose, 2-ketohex with C is equal to O at C2, all share the same 1,2-enediol intermediate when treated with base. The stereocenters at C3, C4, C5 are identical in all three. C3 has HO on left, S configuration, C4 has O on right, C5 has O on right, and C6 is CH2O. And for the final step, the enol form shown, 1,2-enediol, is the common intermediate for D-glucose, D-mannose, and D-fructose. Tautomerization of this enediol can yield any of these three sugars depending on which carbon the proton is added to and on which phase. Why options A, B, and C individually are insufficient? The enediol intermediate is not exclusive to any single sugar, it is shared by all three. Therefore, saying it is only the enol form of glucose, or only mannose, or only fructose would be incomplete. Since the given enediol is the enol form of D-glucose, D-mannose, and D-fructose, the answer must be all of these. Therefore, the correct answer is D. Therefore, the correct answer is option D.